already? Everyone here? Cool, all right. Yeah, today we're talking about Terraform, and actually particularly talking about authoring production-grade Terraform. I was chatting to JD and a couple of the guys beforehand because it was got asked to do a talk about Terraform, which I've done an awful lot of. I've probably written over 100,000 lines of Terraform, all sorts of different projects for all sorts of different resources and different use cases. So feeling fairly qualified to talk about it, but it's when you work with something so much, it's quite hard to approach doing a talk because you can talk about how do you deploy Terraform, how do you write Terraform. So today I kind of wanted to deliver how I approach writing Terraform after having written hundreds of thousands of lines of it, how I get my team to write Terraform, and how I try and instantiate a way of working that lends itself well to producing ultimately production-grade sort of mission-critical infrastructure, and some notion of writing reusable modules that people can easily consume and can consume safely. So we'll talk about that today. Sort of the obligatory "here's me" slide with a bunch of certifications. It's not to show off. If anything, I just have an awful lot of renewals to do every year, which is a bit of a pain, to be perfectly honest. But yeah, I do genuinely work across all of these areas. I work for a consultancy called Ascent. We do software engineering, we do data engineering, we do data science. We do a lot now with Gen AI. I've built everything from Gen AI platforms using Azure OpenAI to plain massive VM platforms with sort of old school legacy Windows IIS and things like that, and everything in between. Lots of Kubernetes actually recently as well. And in particular, the bottom one in the corner there, I do everything, absolutely everything I can with infrastructure as code and with Terraform. So this is what we're talking about today. The main takeaway actually from the talk, the main thing I want to gift with this talk is the workflow, right? It's like, how do I write good Terraform? So I'm hoping to show you some tools and techniques. I'm going to try and demo that, internet permitting. And then I'm going to talk a little bit about some tips and techniques. I'm going to have a little rant about naming conventions because it's a particular gripe and it does lend itself to Terraform. And then I'm going to end with the big picture of like, why Terraform? How does that fit in a kind of platform engineering landscape? So we'll kind of dig into the workflow. If you've ever looked at HashiCorp's website and looked at Terraform, this is pretty much what they'll tell you in terms of the workflow. You write some Terraform, you run a Terraform plan, you get a nice plan output, and then if you're happy with the plan, as a conscious human, you've read the plan and you're happy that you're not going to destroy some database that you shouldn't be destroying, then you apply the plan and stuff happens. And stuff can happen in Azure, it can happen on a vSphere cluster, it can happen in AWS. Obviously, for the people here, we're talking about deploying stuff to Azure. But the pattern's the same. And really we're looking at, in this talk, we're looking at the right element of that. And the first thing I kind of want to introduce, and hopefully it's something that's fairly obvious to people, is it's a Git workflow. So the workflow is very similar actually between the two. If we're talking about working with Git, and this workflow is completely based on working with Git, so we're talking about version controlling our infrastructure code as point number one, should be fairly obvious. When we're working with Git, we write our code, we add code to the staging environment of Git, and then we commit that code. And then we can repeat that cycle, and eventually we've come up with the code we want to deploy, in our case with Terraform, and then that's when we would run our plan, run our apply. So you can imagine this Git workflow of write, add, commit, write, add, commit is like an inner loop around the broader loop of write, plan, and apply that we're doing with Terraform. But if we're talking about good engineering, and we're talking about writing production-grade infrastructure, there's kind of something we want to include in here. If we're going to be good developers, let's say, we want to have some form of check, right? Like I'm writing code, and ideally, in a perfect world, when I do a commit for my code, I want every single commit to be as perfect as it can be, right? I want a good history. Anyone that's worked with large repositories and especially Git repositories, you would no doubt have seen horrendous version histories of added this feature, oops, fixed this thing, oops, yeah, that wasn't right, I'm fixing this again. 17 commits later, like they've got to the point where they needed to be. But ideally, it should all be baked into one commit. And you could maybe say that's a bit of a skill issue with Git, which is fair to say. But for those who are maybe less familiar with Git, like this is the workflow for Git, and we want to make sure we have some sort of quality assurance really built into our workflow. And we can either do that as sort of competent, conscious humans, which requires a lot of knowledge and a lot of pedantic checking of our code, or in the DevOps world, we can use tools to do that, which we'll get onto in a minute. But like, what are those quality checks that they're looking for? So we're looking for code that's written in a consistent style and is legible and maintainable. That should be fairly obvious, right? If especially with large code bases, you want code that's easy to read, easy to maintain. You obviously want it to be syntactically correct. It needs to actually run. We want documentation. I think it's fairly easy to say. There's no argument against documentation. We want people to be able to understand the code we're writing. And we want people to be able to consume the code we're writing, especially when we talk about things like Terraform modules. We want resources ideally to adhere to best practice configuration, right? So if I'm writing a resource definition for a resource, a service bus, whatever it is, I want to make sure that the attributes set for that resource are going to lend themselves well to best practice configuration. And sort of tangentially to that, we've got, that configuration should really adhere to security standards. So we should be thinking about things like security and compliance, like a storage account should by default use TLS 1.2 at a minimum, right? There's many, many, many security controls that we can conceive of that we should bake into these resources wherever possible. And ideally, all of those things should be encompassed in some sort of CI/CD pipeline, maybe a bit advanced, but maybe we can do something with that locally as well. And so like any good DevOps engineer, you could do all this manually if you were really pedantic, especially if you're doing it for every single commit. But in the DevOps world, we like to use tools. So the core of this workflow has got a few tools. I'm going to mention a few tools. There are more tools you could use. I use 5 tools. 2 of them technically are baked into Terraform, as you'll see, which is a little bit cheating. But hopefully, we'll string this all together and you'll see how this works. And we'll do a little demo afterwards. So tool number 1, super obvious, but I never see people use it, and it really annoys me because it's dead easy. It's baked into Terraform. It's called Terraform Format. The actual command is Terraform FMT. What does Terraform Format do? It's a code example on the right. It's an Azure Resource Group. It's got 2 properties. If I run Terraform Format, it makes it look a bit nicer. There's a bunch of other stuff it does too, but really simple stuff. But okay, for 1 resource, it doesn't particularly matter, but for 1,000 resources, it just makes things a bit easier to maintain. And there's really no excuse for using it because it is built into the Terraform CLI, right? I can just, if I have Terraform installed, I can run Terraform Format. It takes a millisecond to run, right? It's dead simple. And it just makes our code a lot more maintainable. Similarly to that, another tool built into Terraform, Terraform Validate. And again, this one is less used. Again, there's no real excuse for not using it because it's built into the Terraform CLI. It will correct some issues. Now, if you're using a modern IDE, it will tell you these issues before needing to actually run Terraform Validate in most cases. But I guess we could make this slightly interactive. There's actually 7 things wrong with this code block. Be interested to know if anyone wants to shout out anything. There's some obvious ones. There's maybe some less obvious ones. Doesn't have to be interactive if people are missing an equals, yeah, so number 1, that's fairly obvious. Anyone else got anything? Spacing's fine.
Space 7.
Yeah, the 7, yeah, that's a string. It shouldn't be a string, it should be a number. That's 1. There's another one like that. Yeah, names missing and equals, yeah, we had that. False, yeah, that should be a bool, yeah. So that's a few things. Resource, capital R, fairly innocuous. In fact, to show you. So yeah, we had a few of those. Obviously, the equal sign, fairly easy. I've been a bit cheeky. Variable, undefined. If you've said, maybe you're doing development you've said, oh, okay, well, the SKU for an Azure Key Vault, I want to make that variable. I want people to just tell me what the SKU is going to be. If I then carry on writing code and I forget that I need to write in that variable, it's obviously undeclared, Terraform Validate is going to tell me about that. Obviously, your IDE probably is going to tell you about that too. So Terraform Validate, fairly covered if you're using like the Terraform plugin for VS Code. But again, it's built into the CLI, like just run Terraform Validate. It will tell you if things are going to work. It will also tell you if you've downloaded your providers and that sort of thing. So yeah, no excuse for those. But so we've got two tools built into Terraform. I'm telling you about them because I see an awful lot of Terraform code get pushed to remote repositories where people haven't even bothered to run this, especially the format. It's really annoying. Just do it, please. We'll get to a workflow that will automate this kind of stuff, so you don't really have to think about it, but it's jumping a little bit ahead. I want to introduce now 3 tools that are not baked into Terraform, but they are all open source, and they're really cool tools. And actually, they're tools that I think help differentiate Terraform from products like Bicep. And this is why I think Terraform is really cool, is because as a, well, not recently open source, but historically open source product, or you could use this with OpenTofu too, there is a really great ecosystem of tools around Terraform. So like I said, there's more than the 3 I'm going to show you today, but these are the 3 that I personally use in my workflow. It's the workflow that I get my team to use. It's the workflow I build into CI pipelines. And the first one of those tools is a tool called TFLint. It's open source. And the way I kind of describe this, I mean, obviously, if you know what linting is, you'll be familiar with what TFLint is going to be doing, but I call it like advanced error detection. And really, it's also enforcing conventions. It's doing that for Terraform in a sort of agnostic sense, but really cool is that there's a plugin for TFLint which has over 200 connectors or 200 rules for Azure-specific resources. So this has some really cool capabilities where if I've written a resource and maybe it's missing a particular attribute that it should have, or if it's got a misnamed attribute, there's actually 4 errors with this code, if anyone cares to have a hazard a guess at that. A couple of them are convention related, so not breaking, but just lacking convention that you would see, and 2 of them are actually breaking. If I was to deploy this or plan this, it would fail. I'm interested to see in 5 seconds, see if anyone spots anything. No. And this is my point, right? Like if you're developing or somebody, you're reviewing a pull request and you see this, you might not immediately think anything's wrong with that. But if we have tools that can check these things, we can global, yeah, that's wrong. Shouldn't replication type global, it's not really a thing. Yeah, it should be GRS if you were going to be global replication, right? So, TFLint will pick up on that. It will say, okay, well, account replication type of global is not a thing. Like, why are you doing that? It should be one of these values. Account kind, that's actually not the attribute name. There is an attribute on a storage account called account kind, but it doesn't equate to standard. And this is one of those weird things which, when you do a lot of Terraform, you'll bump into, you'll forget. So TFLint really sort of helps with these sorts of issues and a bunch of other things as well. Like I said, there's over 200 rules for Azure-specific resources. And also at the top there are just general Terraform stuff. So like conventionally, the names for your resources, in this case, example storage, should follow snake case. That's just the way that most people write Terraform. You can disable rules individually, right? So if you have a particular convention, if you write all your comments with // it's fine, just disable the rule. TFLint, it's just, it's a linting tool.
Sorry, so how do you run TFLint?
We will demonstrate TFLint. We will demonstrate it all. Next tool, really cool tool. There's a couple actually that do what Checkov does. So Chekhov's awesome. Again, cloud agnostic. So you can run this tool with AWS resources, with other things too. It's a security scanning tool. So similarly to TFLint, it will look at your resource definitions, and it has, again, a whole bunch of rules. I forget how many. I mean, it's over 300, I think, for Azure-specific resources. It will look at your code, and it will tell you if something's not quite right with it. So in this case, this one's really cheeky, actually. This code block is the same as the one before, so we've rectified our issues. We've said, okay, thank you, TFLint. I have, atoned my sins. I have corrected my code, and here is some working code. And this will work this will run. There's nothing wrong with that. In fact, actually, that's the example. If you ever go on the Terraform Docs and you ask for a storage account, that's the example code, pretty much. If you were to run Checkov against that, there's actually 4 things that this will error on for security reasons. Anyone has a guess? It's a lack of, there's some attributes that from a security perspective, you probably should have, right? So again, if you're reviewing some code, can be the most competent, most expert Azure person in the world, if you read this, nothing's actually wrong with it, right? So you have to be really on your game if you're going to review something like this and block that PR because of security reasons. Like, you need to be really thinking through every single possibility of what a storage account can do. This is why tools like Checkov can really help. It's open source, again, different license, but it's still open source. Comprehensive library of checks for Azure resources. If anyone cares, then if you run Checkov against the default example for an Azure storage account, you will see public access is enabled by default. Things like TLS. I think actually nowadays TLS 1.2 is the default for a storage account, but for a very, very long time it was not. And basically, in any case, Chekhov's telling you to be explicit, right? It's saying, like, even if it is the default TLS 1.2, it shouldn't be anything less than that. So you should at least, in your Terraform code, like, explicitly say that's what it should be. Now, there's some optional ones here, right? There's checks that maybe I want a public storage account. Maybe I don't care about queue logging, right? Because why would I? To be perfectly honest, I'm not really sure why that's a check, but Chekhov's extremely comprehensive. It's more comprehensive than other tools, and this is why I use it. There's another tool called TFSec. There's other security tools as well. If you actually compare the checks for Azure specifically, Chekhov's got way, way more checks than a tool like TFSec. So that's generally why we go with it. If you want to, it's open source, yeah. If I want to exclude a check, it can be done for any checks. There's kind of 2 ways you can do it. All of these tools, you can have a configuration file for your repository, so you could exclude a check sort of globally for your module, or you could do it per resource. And the way you do that is just have some, has to be in this format. So a comment with Checkov : skip, and then the ID, in this case, CKV Azure 33, which is our queue logging. I'm saying I don't care, I'm not using queues, I don't need to enable logging for that. And if I do that and ran Checkov again, then I would have one less thing to fix. And the other ones, generally speaking, and we'll see it in a minute in the workflow, the other thing Chekhov's really good at is the errors will give you a link to a page which actually tells you what the configuration should be. Most of the time, it's literally just one attribute that needs to be set, right? Now, you need to be intelligent about it. Like I say, if you're going to disable public access, how are you going to make access to that storage account, right? You need to think about, am I going to use a private endpoint, a service endpoint? Does it even need to be private? If so, then maybe I just skip the check with some reason, and that's the other thing. You should put a reason in here. One of the things I won't demo, but I will mention that we're here. Chekhov's really good for CI pipelines. You can actually export the results in JUnit format, which is really well supported in Azure DevOps and nowadays also in GitHub Actions. And you get a really nice, pretty report, like a graph breakdown of how many checks passed, how many failed, how many were skipped, what the skip reason was. So it's a really, really awesome tool, actually.
The other thing as well, actually, is that although you might think this is slowing you down initially, but it'll probably save you a lot of time. What you find, you won't be backwards against visual policies.
Saves you a lot of time. Yeah, definitely. A lot of this stuff, it all comes down to the DevOps principle of like shift left or fail fast, right? It's like, I want to know this stuff before I'm deploying it to my production infrastructure. I want to know it before I've deployed my production infrastructure that everything's secure. It's an assurance, it's a quality gate, right? Now, like, yeah, we'll bake it into the workflow in a minute, but one more tool to mention, and it's my favorite tool. It's a tool called Terraform Docs. There's a snippet of what Terraform Docs does. Terraform Docs, open source again, really awesome. Looks at your Terraform code, so looks at all of the resource definitions, all of the variables, all of the outputs, all of the providers, takes all of that and generates a markdown page, so like a README file in your repo, and it builds you these beautiful tables, beautiful, questionable word to use. This is the kind of documentation that if you were ever to write this by hand, you would probably be insane, and it would be impossible to maintain. And actually, if it was written by hand, a consumer should be incredibly dubious of the fact that this would be up to date, because again, you would have to be insane to maintain something like this. So the fact that Terraform Docs can automate this for us, whenever we add a new resource, whenever we add a new variable, whenever we change the description for a variable, we can run Terraform Docs, and our documentation is going to be automatically updated. And we'll see that too. So that's a snippet of some of the output that we see. We can see what resources I'm using in my module, what inputs there are. We'll see this in action, and we'll sort of abuse it a bit more if we can get some time to do that, because there's some extra cool stuff you can do. So if we go back to our sort of workflow, we've got, we're doing Git, so we're version controlling everything, we're writing some code, we add our code. We now have these infrastructure code quality checks, which we've, turned into a list of tools. And at this point, you're probably thinking, well, that's nice. But if you're telling me that every single time I write some code, I need to run 5 tools, that's a bit silly. And I would agree with you. Like, you're not going to manually run all of these tools every single time you change a piece of code. So again, as a DevOps person, we look to automate that. And the final tool I want to introduce in this workflow, and it's the tool that sort of orchestrates all of these tools together, is a tool that hopefully some of you have used before because it's awesome. It's a tool called pre-commit. Pre-commit is nothing really to do with Terraform. It just happens to have some Terraform hooks. What is a hook? When you run pre-commit, it runs off to the back of when you run git commit. So you type git commit with a message to commit. Pre-commit injects itself into that flow, and it will run some hooks. And some of the hooks it can run are things like the tools we've used. So it can run Terraform Format, it can run Terraform Validate, it can run Terraform Docs, TFLint, Checkov, and there's some generic ones too, like we can fix the end of our files. Don't commit to branch, really cool. That will prevent you from writing directly to the main branch. So you can enforce things like feature branches, so people can only develop in a feature branch, not directly to main. This is even cooler because a lot of our tools actually fix stuff for you, right? So Terraform Docs isn't just telling you that your documentation's out of date. Terraform Docs fix your documentation. Terraform Format fixes your code, right? And so by just simply running pre-commit, we automatically update our documentation and we automatically format stuff. And also Terraform Validate, TFLint, and Checkov will then warn us of any issues. The commit will not go through until all of these checks pass. So what we actually end up with is what I was talking about before. We have this flow now where I write some code, I add my code to my repo, I can work through these issues, and every single commit is effectively as perfect as it can possibly be. And it means in a sort of version control format, I know every single commit, my code, my infrastructure code meets security standards as much as possible. It's stylized correctly, it's syntactically correct. It's all of those points, the documentation is up to date. Every single step of the way, right? Every single commit, I've passed all my quality assurance checks. So that was a kind of high-level theoretical view of the workflow. I kind of wanted to just demo that now, which hopefully we can see. So I was going to do this in a code space, but I'm tethered on the internet, so we'll see how this goes. I hope you can see all that pretty well. That's about as zoomed in as I think I can be. What I'm using here is my Terraform module template, and I'll send a link to it. There's a QR code on the end of this presentation, so if you do plan on writing any Terraform soon, I have a template. This template has a dev container in it, so if you want to use GitHub code spaces or you want to just build that container image locally, all of the tools are installed, available for you. There's a config folder which has config files for things like Checkov. I'm sorry, the projector's a bit off, so apologize. And it's got some stuff baked in already, so it's ready to use. I've simply just added my subscription ID for this case to be a bit simple, but we're going to start with some stuff. So if I write a resource, I'm going to write Azure RM, resource group, and then SOG For a resource group, we need a name, and then we need a location. Right. Is that right? See, I can't even write properly. There you go. Yeah, so, okay, I've written some Terraform. Nothing wrong with that. That will run. But like I said, we want to run these tools. So I'm going to run them manually to begin with, just to show you each one individually. But I've got Terraform installed. If I do Terraform FMT, nice. Makes it look a bit nicer. That's cool. What else can I do? Terraform Validate will fail, actually, because I haven't initialized Terraform, but it can fail for all sorts of reasons. So it's telling me at the moment I haven't downloaded my provider. So it's basically telling me I need to run Terraform init. So that should, well, actually, tethered internet, we'll see about that. Hopefully it won't take too long because we can get through some other stuff. Not that it matters particularly. I'll give it a sec. It goes through everything in the folder, yeah.
Go to do the case. Format.
It does have a, so usually I run this, so with pre-commit, I mean, we can look, so actually, like I say, config files, there's a config file for Checkov, Terraform Docs, and TFLint. There's also a config file for pre-commit. So I think basically the only arguments I pass in is the config file. Yeah, I would have to look at the checks if there's a recurse flag. I seem to think there is a recursive flag. When I run it manually in a CI pipeline, I think I do recursive. I apologize for the internets, but maybe we don't need it, it's fine. So yeah, we can validate stuff, that's nice too. If we do TFLint, so let's say I was gonna not stick to convention here, so I say I'm not using snake case for this. TFLint, I think I have to initialize it first. Do I have to initialize it? Yeah, and just config. I apologize. Always live demos are a bit awkward. It's already installed, so that's nice. TFLint. Oh, actually, there's no issue with this. What am I going to do? Let's do another resource. Like we'll do Azure RM service plan. This will tie into some stuff later on. So this is an app service plan. And thank you, GitHub Copilot. That's actually wrong, though. I think actually we want OS. And the other one is, yes, uname. Yeah, B1, whatever. Yeah. I think, to be honest, if we do something like this, TFLint's going to, obviously my IDE is telling me, but yeah, TFLint, one issue found. Yeah, oh, it's telling me now about the resource naming convention. It's not correct, so you kind of get an idea for that. Let's fix this. If I do Terraform Docs, then let me just clear this. Terraform Docs is quite useful. So right now, README file, I have so because we're using a module template, I've initialized Terraform Docs. The way it actually works is in my README file, I've got these kind of comments. So begin TF Docs and then TF Docs, and that's how Terraform Docs knows how to inject the different sections. So by default, it has sections for the providers, and right now it's just saying no providers, no modules, no resources, and we'll see how that changes. So right now I have some more resources. So if I save that, Terraform Docs, you have to give it the directory, which is in this case just the root directory, and then I think it's also config file. Terraform Docs, just config, isn't it? I knew it. Okay, great. Apologize for my tardiness. Usually I do this on a code space. Okay, README updated successfully. So if I go back to my README, it's added stuff. I can see I've now got resources. Now obviously this is Markdown, which is not super nice to read on its own, but I can open the Markdown viewer and and sometimes it doesn't update until we do the git commit. But you get the idea, right? So it's added some table for resources, and like I say, if I was to write this by hand, I would be insane, but this is really cool that I can just generate that. Final thing I want to run then is Checkov, which I think also has a config file. And you get the idea as well, like if I'm to run every single one of these tools manually, every single time, it's a massive pain in the ass, which is why we have things like pre-commit. So Chekhov's gone away. I've got now 3 issues, right? And it's stuff that we didn't see before because there's actually technically nothing wrong with this, right? Like this is the absolute bare bones of an app service plan. It's a Linux app service plan on a burstable SKU. So what's wrong with it? Ensure app service plan is suitable for production use. I'll see if this loads. Like I say, internet permitting. Apologies for tabs. Yeah, that looks quite fast actually. But this is the kind of detail you get. So it's basically saying, here is the check, gives you a nice description, and it's basically saying, well, the SKU for production use should be premium, which in this case, I think the minimum SKU is P1 V3. I think actually nowadays is a P0 V3, but if I was to change this then to P1 V3, that will in theory fix our issue. The other one is things like zone redundancy. So it's saying you should enable zone redundancy, which I know is called zone balancing enabled, and I set this to true. And then the final one is saying you should have a minimum number of instances. So in an app service plan, you can have multiple instances of basically the IIS VM that's running this thing, and that's called work account. If we set that to 2, this is, thanks to Checkov, we've now got some better controls. This is a better app service plan than we had before.
So listen, so Checkov doesn't actually just check the security. It actually looks at the redundancy and the high availability of that service as well.
Yeah.
Balancing doesn't mean it's more secure, it just means it's more resilient.
Yeah, I mean, that's a good point, right? So it's not strictly security if something's got load balancing enabled, but I guess from a sort of resiliency, business security, business compliance perspective, I don't know. Yeah, like, from a business perspective, this is a more resilient and therefore, a more secure service. So we've got a better result. Yeah.
I guess you've got to appreciate as well the costs that come with that as well, because someone might run Checkov and think, well, premium SKUs.
Yeah, I mean, one of the tools I haven't mentioned, but it's a really good tool, is a tool, is it Terracost or something like that? And that will do the FinOps piece. So that will look at your configuration and it will go away to the Azure API, check the pricing. Anytime you make a change, it's going to say, oh, your change from going from service bus standard to premium, that's plus £700 a month, please. So you'll know that from your Terraform plan. So that's another tool. I haven't included it in this workflow, but one to use. So yeah, we can work towards this point here where we get our, checks are passed, happy days. Yeah, fantastic. So we've got that better now. Obviously, you're not going to run all these tools manually every time because that would be really silly. So what we can do, if I do actually do a new branch, because otherwise pre-commit's going to moan at me, I do my git add, and now I'm going to do my git commit. Add service bus on the line, add app service plan. Why isn't it done? Pre-commit install probably or something like that. Cool, okay. Great. Always love a tech demo, but you get the idea, right? So I'm running some things. Trim trailing white space has failed, so it's fixing the white space in my file. You can see it's automatically run Terraform Format because it's aligned everything for me, and in fact, Terraform Format has told me it's modified main.tf. Terraform Validate, what are you doing? Okay, we'll hop out of the demo because hopefully you get the idea, right? And usually, like I say, I'd run this in a code space, which would be a bit smoother, but just because I'm on a tethered internet connection, it's a bit awkward. So, yeah, so bit of a demo, tips and techniques. One thing I really wanted to mention was variable validation. You can't talk about variable validation without mentioning Bobby tables, classic XKTV. I wanted to kind of demo this in the workflow, but because it ties in actually to some of the tools. So like we had with an app service plan, in this case I'm talking about container registry, but we have some variable, right, SKU. And the default, we've set the default, which is something you should probably do. Right, what's wrong with that? Well, the thing that's wrong with this is I can put in anything. And I don't, we should be a bit more careful about that. So something I never see anyone do, and it is quite important actually, is you can use validation blocks in your variables. So this is an example here. You can validate against the input. So for Azure Container Registry, it can be a standard or a premium SKU. You can set an error message, and you can use any sort of basic operators like the OR operator here. You can be a bit more fancy if you want, and you could use an inbuilt function to Terraform, like contains, very common validation block. You have, contains and then a list of things, particularly for SKUs. Some resources have many SKUs you can pick from. But you can use this to control, your module, right? So if I have an app service plan, maybe I don't want to let people use the standard SKUs because actually those are now sort of deprecated. I don't know if they're deprecated, but I can say, well, you're only allowed to use premium SKUs, or maybe you're not supposed to. You have a question? Or?
Right, so if you were to declare a variable, will this pick up what you set in the variable? So if you were to set a variable to standard, that would declare as the variable picker.
So if the default is set to something that you shouldn't be, would it pick that up? Is that what you're asking?
Yeah, that's what
I believe so. I've never tried that because, usually, the default you set is going to be in the validation block, but I'm pretty sure it would fail on that. But the point is this will fail at plan time, which is really handy. So sometimes if people give the wrong inputs, not for everything, but for some things, plan will sort of just accept the generic input, and then when you actually go to apply, you'll get an error message at apply time, which is what we really want to avoid, especially if you're trying to deploy production infrastructure. So there's a few tips on here. You can actually have multiple validation blocks within a variable, so it's useful to comment those. Try and provide a useful error message, obviously, because that's what people see when this fails. And provide sensible defaults. The sensible defaults thing is really important because if you're writing a Terraform module, what you don't want is to have no defaults and somebody consuming your module then needs to provide like 15 inputs to configure everything. Ideally, everything should have some sort of default, and ideally that default should be something quite secure. So, maybe you want somebody to be able to control the SKU of your Azure Container Registry or your app service plan. Maybe by default you set that to premium because ideally that's what it should be. If somebody wants to use a burstable SKU because they're using it in a development environment, they should explicitly set that, right? It's like trying to set people up for success straight out of the box. One of the things I commonly see though is that eventually people do stuff like this, right? So in this case, Azure Container Registry could be an app service plan as well, to be fair. We now have another variable. I want to control whether or not we enable zone redundancy. But there is a problem with this, which is that whether or not zone redundancy can be enabled depends on the SKU. So now I have two variables that kind of interrelate with each other. And so the first thing you might think to do is say, well, okay, what's the problem with that? I just have a validation block, and what I'm doing here is I'm saying, well, either the SKU can be premium or zone redundancy can be disabled, right? So if the SKU is premium, then I can have zone redundancy, and if it's not, then I can't. The problem with this is you can't actually do cross-variable validation. The latest version of Terraform, as of like last week, they made available this feature. They call it a language experiment, which doesn't fill me with a complete sense of confidence for deploying production-grade infrastructure. So I will still say that this stands for now, the tip that I'm about to show you. This will not work, just plainly won't work. But we do still have this problem, right? Like we have two variables that are dependent on each other, but I can't validate against each other. So what can we do about this? Because I see this all of the time, and this is a really common way to solve this problem. So if we get rid of those variables and we look at our SKU again, what we can do to solve these sort of problems, and they are generally really common, we can turn this into an object type. So we can say, okay, well now our SKU variable, rather than being a string of like standard or premium, it's got multiple attributes. We have an attribute for name, which again is whether it's premium or standard, and we have an attribute for whether zone redundancy is enabled. And we can still set those defaults, we just do it in a slightly different way. So the default for the variable as a whole is just a blank object. And then for our independent attributes, we can use this optional keyword. And so we can say, okay, well, the default SKU is standard, and the default of zone redundancy being enabled is false, because you can't use zone redundancy with a standard SKU. So we can still do what we were doing before. But now what we can do is we can actually have our validation, because now that we're in that variable, we can validate against the different attributes of that variable. And actually, you can be a bit clever about it. So what I've done here, we've actually kind of got two validations in one, because if you sort of compute the logic of this condition, we're basically saying the SKU name can either be premium, otherwise it needs to be standard, and zone redundancy needs to be false. So in one validation block, we're saying we're making sure that the SKU name is either standard or premium, and that if it's not premium, zone redundancy has to be disabled. So we're solving our problem. We've kind of got a bit more of a mature approach to how we deal with variables. We can support complex validation scenarios. And like I said, this is all shifting towards failing a bit faster, making sure that we're preventing these stuff from getting to an apply stage where it would ultimately fail.
Could you go a bit ahead to say, if it is set to premium, then default is true, which would solve the thing?
I think, yeah, I mean, the defaults, you couldn't really do like an if condition in the optional block, if that's what you're saying. For the default, you'd have to kind of think about it yourself. You'd either have the default as premium, with zone redundancy set to true or false, or you would do this. It just depends on who's consuming your module, what the correct decision might be for the default. Like I said, there's often cost implications. If this was a service bus, you might not set the default to premium because of cost, right? But in some cases, like an app service plan, actually the lower tier of premium is quite affordable and does afford you some quite good features. So you might say, well, it's reasonable then to set that as the default. So that's kind of up to you, really. But no, you can't do some sort of crazy if statement. But the validation blocks can get quite large if you want them to be. Try and be clever about them. ChatGPT, GitHub Copilot, very good at writing complex validation conditions, I will say. So yeah, but there's kind of something wrong with this, lastly, if we're talking about like consumption, and that is that this description kind of sucks now. It's just one line. Like, this is now a complex variable. This isn't just a string. This isn't just true or false. This is some object with multiple attributes. Could be loads of attributes. Could be, some complex data structure, even where we've got an object with nested objects. It can, you can get some really complicated scenarios with this. So what can we do about that? And this is really nice because it hooks into some tools, right? So firstly, we can do a multi-line comment. We can use here doc syntax, which is this, I don't know what that symbol is even called, triangle, double triangle, EOT is the sort of convention. So between our sort of EOT tags, we can write multiple lines of text. The fun thing that I'm doing here, the main thing I'm doing here is I've got a code example, right? So as a consumer of this module, you can see, okay, well, this is the data structure that this variable is expecting. It needs a name attribute, it needs an enable zone redundancy attribute. Technically it doesn't because they're optional, but we're describing, the shape of the data that we're expecting to configure the SKU. But what I've done here as well is I've written basically Markdown format. So I've got 3 backticks. So I've got a code block in Markdown. Why have I done that? It's because when we use Terraform Docs, which is one of the tools we mentioned earlier, what does Terraform Docs do? It goes through all of our variables, it goes through all of our resources, converts that to Markdown. And what's really, really, really cool is that when it reads this is written in Markdown. So what we actually get in our Terraform Docs is an actual code block. So it's really nice to see. So yeah, use here doc syntax for multi-line descriptions, try and provide, some description. I've obviously minimized the validation block. You can kind of see, like, we've gone from a variable that was like just a string, and we had another variable which, kind of related and depended on the other variable's value. And now we've got this kind of more comprehensive variable. So I'm trying to paint this picture of, like, when you're writing Terraform for production grade infrastructure and you want to have these checks in place, like, there's a lot more you can do even with just a simple variable. And to give you an idea of what this looks like when Terraform Docs renders it, not with this exact example, but here is an example of one of the modules that I wrote the other day. So this is a variable for network access. And it's complicated, right, relatively. There's 4 attributes, 2 of them are lists, 2 of them are strings. If this was just a one-line description for my variable, like, what would it be? Like, just an object that describes network access. Well, great. What is that object? What are the attributes? Like, having a code example makes this super, super easy. And paired with Terraform Docs, it means if I'm consuming a Terraform module, and it might be me 6 months later, not remembering what I've written before, like, this is super easy. I can go, oh, I know how to configure this now. It takes 2 seconds to look at, and I can figure out how to configure stuff. So just conscious of time. We'll blast through this one. I just want to have a little rant about naming resources, because it's really hard and it's annoying. I often see stuff like this. Storage account name, the name of the storage account. Simple, happens all the time. I go to so many companies and I read through their documentation about naming convention, and it always sucks. It's complete trash. No regard for the limitations in place, and every single resource in Azure has a different limitation for the length, the number of characters you can use, which characters you can use. Some have words that you can't use. There is a page on Microsoft Docs, it's extremely long, that will tell you the limitations for every single resource name. What can we do about this? In fact, particularly with storage accounts, I think, the limit is 24 characters, which is actually very small for a resource that, by the way, needs to have a globally unique name. Can't have any spaces, can't have any funny symbols, no hyphens. It's just, lowercase letters and numbers. But if you go to companies, they'll say, oh yeah, no, our storage account, it must be stprod01. And you're like, well, okay, that's taken. And that's exactly the problem. And I have had this scenario where I've deployed dev, test, prod with some sort of, not very globally unique name, you could say, and got to production and that name's taken. I have had that scenario multiple times, and it's really not cool. The other thing that's not cool is when you delete these sorts of resources. Storage accounts have a soft delete, key vaults have a soft delete. If you delete, my key vault 01, and then you want to redeploy key vault 01, name's taken, because it's soft deleted for 30 days, 90 days, whatever. So then you get into this awkward thing where it's like, well, now do we increment the thing? So names are stupid. So can we do something? Well, we can do something about these bottom ones here, right? And it's a thing we've learned about just recently. We can do variable validation. You can use regex. You can use ChatGPT to generate regex for the conventions. Again, we're using, here, doc syntax, right, for the error message this time. So if somebody, doesn't provide a name that meets the limitations that we have for the storage account, they don't have to interpret some horrible regex expression. We've kind of clearly explained what that needs to be, right? So we kind of solve some of the limits, but we still have this annoying thing, which is storage account names must be globally unique, and that's a lot of resources need to be globally unique. With names, no, not really. You just kind of need to, names are kind of up to you. And there's some stuff which I'll mention now, which we can do to kind of help this part, which is, we can fix the limitations with some sort of regex, and that gets us around those things, and we can protect against that, so people don't need to look up the documentation to see what the limits are. We can enforce that with the validation. The thing I really want to highlight is this notion actually of making resource names optional. So on the face of it, we set the default to null, right? Don't even provide a storage account name if you don't want to. We change our expression to allow null values. So we have a variable storage account name. There's a couple of resources I like. There's actually a random provider for Terraform, so separate to the Azure provider, there's a random provider made by HashiCorp. My favorite resource, random pet. It's, lazy elephant, something like that. And then a random integer, 3-digit integer. You can combine these. You can make a nice sort of resource suffix for yourself. So you can have, crazy hedgehog 369, with an ST in front to denote that it's a storage account if you want. And we can sort of generate these, random names, and usually this is actually enough to get us globally, well, it's very mathematically going to get us globally uniqueness for our resources. But what we can do is we can still have that storage account variable, right? Like if somebody provides a storage account name, you obviously want to use that over our generated name. You can use probably one of my most used functions in Terraform actually is called coalesce. Don't really know where the word coalesce comes from. I think it's actually from SQL, but if you actually look it up in the dictionary, it's got kind of a weird definition. So in this case, in Terraform, it basically means take the first non-null value. So if storage account name is provided, it's going to use that. Otherwise, it's going to use this generated name. And this is actually just really useful. It's really useful for things like dev environments, test environments. I just want a storage account. I'm not going to bother giving it a name. It can be, Fat Pigeon 365, right? It doesn't matter. Part of the reason it doesn't matter. Here's an example, actually. So these are some resources for Synapse. Every single one of these, just within a Synapse workspace, different length requirements, different character validation. It's ridiculous. And if you say, well, using random resource names is a bit silly, no one would ever do that. Here's a print screen from Azure Machine Learning. This is just one of many examples. Every single job in Azure Machine Learning is green reggae something, or upbeat puppy. GitHub Codespaces uses this convention. So many things nowadays just give up on names and just say, just generate me a random thing. It's totally normal. But obviously, we need some way of identifying what stuff is. So better than naming things is use tags. Please just use tags. Use tags for all of the things. Tag your resources. Having metadata for resources is infinitely better than naming your storage account prod 01. You can have an owner tag. You can have a business owner tag. You can have an environment tag. You can have many, many, many tags. In fact, I'm not even sure what the limit is for number of tags, but you can have an enormous amount of metadata for resources. And it's dead simple to add it in Terraform. There's obviously Azure policy, things you can do to assign tags to, but we have a variable. It's just a map of strings. That's all it needs to be. And then for every single resource that supports tags, there is a tags attribute, which we just pass in all of the tags. And now all of our resources are tagged without needing some policy to say inherit tags from resource group or something like that. We've just explicitly set tags. So like I said, metadata is just, it blows the resource name out of the water. You don't have to worry about these nonsense resource name limitations. Just name your resources. Thing is my opinion, just throwing that out there, but it's a passionate opinion that resource names suck and you should use tags for everything. If you do find yourself in scenarios where you need to overwrite or add some additional tags to a specific resource, you can basically merge the maps. So you can take in your resource tags that have been provided to the module, and you could merge that with some other tag that you need for that specific resource. The merge function, the latter map, the key takes precedence. So if you had a compliance tag in your resource tags, it would be overwritten by this one, but you could obviously swap those around. And just like with naming convention, Microsoft actually have really good documentation about tags. In the cloud adoption framework, there's a minimum recommended tags, and there's a bunch of additional tags too. So,
does the Azure provider provide any option for setting the tags that the provider and then it apply to all the resources? I find it kept my site name addressing it.
I don't know, but that's actually quite a good idea. I do wonder if that's a thing. I've never really looked at the provider features. I know there's a features block when you do the Terraform provider, but I'm not sure if you can do it at that level. But it's quite easy just to have a variable and just assign it to all the things, but that would be a much more mature approach. I wanted to finish up, appreciating time, just wanted to finish up with like the big picture, because we've talked about code and we've done some coding and, you know, seen lots of code slides. Like, why does any of this matter, right? Like, I have a workflow, I can write some Terraform. Yeah, if you're working in a company that doesn't, you know, write a lot of infrastructure, maybe this doesn't make a lot of sense to you. But if you're working, you know, like where I work with people like JD work, and you're writing infrastructure all day, every day, or you're working in a larger enterprise that has a large demand for infrastructure, then I think having this kind of bigger picture is really important. At the heart of everything that we do, we have resource modules. Now, Jack Tracy was here a while ago, and he talked about Azure Verified modules. What we do at Ascent, or what platform engineering teams in general do, is actually not too dissimilar to what those guys have done with Azure Verified modules. Using the workflow that I talked about, we generally speaking have resource modules for many of the common resources in Azure. So we will take a resource, Key Vault, container registry, whatever it is, and we will wrap around that resource a bunch of standard interfaces. So we have interfaces for configuring private networking for resources that can have private networking enabled. We have a standard interface for doing role assignments when you're doing the provisioning of that resource, diagnostic monitoring, baseline alerts. There's all sorts of things that are really common to every single resource in Azure. Everything has some sort of diagnostic logging capability. Everything has some sort of Azure Monitor alert that you could configure for it. Everything has the notion of role-based access control. So within each resource module, we can sort of wrap around that and build these standard interfaces to configure these things at deployment time specific to that resource. And in that way, what we can do, again, using the tools from our workflow, things like Checkov, things like Terraform Docs, every single resource module can be comprehensively documented. We can be assured that it's meeting security standards by design. We can be assured that everything obviously is syntactically correct. Like, this workflow lends itself really, really, really well to writing awesome Terraform modules that can be easily consumed because of the documentation by other people in the business. So you can imagine if you work for a big enterprise, you could have some platform engineering team that produces these resource modules which other parts of the business can consume. You can sanction resource modules, right? You can say, this is our version of a Key Vault, this is what you must use. And what you can do then is you can take those resource modules and you can build them into what we call stacks. So you can say, well, and this is kind of like a Terraform deployment, right? Like, I have a network, which I've used a module for, I have a Key Vault, app service plan, app service, and I'm building a solution using these pre-built, sanctioned, you know, best practice modules, and I build in a stack. So like a layer of infrastructure. We can have these kind of infrastructure libraries, then we can have common stacks of resources that we can reuse over and over again. I can start actually building like common architectures, which is kind of what we evolve into now. So the way we work, we have what we call accelerators. So we build, you know, a common architecture that makes up, say, a data landing zone using Synapse. We've now got an accelerator that builds like a Gen AI solution using Azure OpenAI and API Manager. We've built these infrastructure layers that we can build into accelerators. And so we can reuse modules. So we have a module for a function app, and it doesn't matter whether that function app is part of a workload landing zone for an application or whether it's part of a data landing zone. Same module, same code, can be reused across both. Don't need to rewrite that, you know, every single time. And same for the stacks, right? We might have some notion of like, here is a spoke network that attaches to a hub. It's going to have things like the VNet, it's going to have NSGs, it's going to have some configurable subnets that we might need. It might have some private DNS zones if they're not in the hub, or it might have some monitoring built in, that kind of thing. And we can reuse that like notion of here is a stack that provisions a spoke network across our workloads. And then finally, sort of how that relates to Azure is each stack effectively, because it's a set of resources that share a common lifecycle, that is what a resource group is meant to be. So every stack gets deployed into its own resource group. We build up these kind of layered resource groups, we build our solution, and naturally each solution is, you know, either it's a shared solution that sits in a subscription, or it could be multiple instances of that accelerator, that environment, which would each sit in a subscription. But we can take that common code base And based on some configuration, we might have a different configuration for prod as we do for dev, but ultimately we can use that same code base and push it to different subscriptions. So we have this principle of don't repeat yourself, right? We're reusing modules, we're reusing stacks. It's all best practice, and we just configure that differently depending on the scenario we're deploying it for, whether in our case that's for different clients, maybe different environments. So just very quickly, overview of the big picture. So in summary, we kind of talked about, we can write syntactically correct code, we can write comprehensive documentation, we can configure best practice for our resources, and we have everything applying to security standards, and we can do that with every commit, like some sort of Uber developer, through the use of pre-commit, through the use of our workflow and tooling. Every single commit is perfect. Like, it's a really cool workflow. I really hope you get to try it. Speaking of trying it, if you want to, there's a QR code that goes to my GitHub, which has that Terraform module template. If you are writing Terraform, or you're going to be writing Terraform soon, please try and use it. Please let me know how you get on with it. Contact me on LinkedIn. If you want to have a chat about Terraform, writing Terraform modules. Like I said, there's a dev container definition in there. So if you have access to GitHub code spaces, you can just run the code space. All of the tools are installed. All of the config files are there. Or you can download that container locally, build it, run it on your machine. So yeah, that was it. I hope that was at least a little bit useful. Does anyone have any questions about anything Terraform related? Because there's a lot of stuff that I said I would like to have talked about, like deployments and things, but today was just talking about writing Terraform, really. Only if people are interested. Part 2, 3, 4. It could be a whole series. No?
Variable, you have modules, you have a naming module that handles all these limitations. But then at some point, when people started using it, complex exists dynamically generated.
Yeah.
Is there any way we can feed that value back to the Terraform Docs and then maybe stores that in Ruby?
For the names?
Yeah, because at some point they figure out so we have to go to the actual resource and kind of thoughts for the name is, because it might have, say, 3 or 4 variables used, and then each variable will have two values. People have to instead of feed that back to the
Terraform Docs only looks at your Terraform code, like the variables, the resources, the outputs, and it just generates Markdown. So unless there's some way that you can get that, I mean, there might be a way you could maybe modify Terraform Docs to get some additional information into the README, but yeah, on the face of it, I'm not too sure, I'm afraid.
So the other one is some of the each one single, I think it had provision in each resources.
Yeah.
So some of the tests people wanted to destroy, that's out of 50, that's 20 resources, they want to destroy and recreate 2 of them. Currently, they just come in the code, we deploy them. Is that an easy way? I mean, I said it's a big destroy. I can use Terraform destroy, it's going to destroy all 20 of them.
Yeah. I mean, that's part of why we do stacks, right? So stacks limit the blast domain, because actually what happens here is that each one of these stacks is a separate Terraform deployment. I didn't talk about too much about deployments today, but we actually use a tool called Terraform, which orchestrates multiple Terraform deployments. And what that actually means is that every single stack has its own state file. It means if I'm a developer and I'm working in that stack with the Azure function, I can delete everything. It's not going to touch anything in the other stacks, because I might have a network engineer writing the stack with all the network resources, and they don't want to be interrupted every time a developer's releasing some new thing in their stack. So we kind of build up this layered approach, and it, like I say, it limits the blast domain of what people are creating and destroying. I mean, I've used this model in pretty much this exact way, where me as the platform engineer was building the lowest stacks with all of the app service plan, the networking resources, and we had 3 development teams writing their own Terraform, but in stacks above that. So they were consuming the app service plan, the network, etc., that we'd provisioned for them. They were then writing their own Terraform for their own app services and function apps and key vaults and things. And then above that, we were writing the Terraform code for things like App Gateway. So we were taking like the outputs from their stacks, like their app service name, etc., feeding it into our App Gateway. But every time I make an update to App Gateway, it's not changing anything with any of the developers' work. It's not changing anything to do with any of my lower network layers. So it's a really, I mean, I could talk about deployments for ages, but this is a really, like it prevents that problem, right? Where you're not going to destroy stuff you shouldn't destroy. All right, yeah, no one's got any questions.